Working hard or hardly working, am I right?
Come on, guys, you're still on the clock.
I finished early.
Hey, I got a math arch nemesis.
Okay. And?
His name is Mr. I think it's Granunson. I need you guys to take him out.
Why would we do that?
Well, if you finish this job successfully, I'll throw in a bonus.
To defeat me, you must solve this riddle.
That makes no sense.
Let's do it.
Joanna jogs along a straight path. For t values less than or equal to 40 or greater than or equal to 0, Joanna's velocity is given by the differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. A. Use the data on the table to estimate the value of v prime 16.
Ah, I see. This is one of those problems that deals with a person going along a straight line and you answer questions about it, right? A velocity and acceleration problem is on the AP exam every year, so it's easy to get all 9 points if we know the tricks of how to solve it. Let's get started. We are given a table of values, and part A asks us to estimate v prime of 16, or, in other words, find the derivative of v of 16. If we look at the t values on the table, we are given 12 and 20. 16 sits right between the two. 12 is 4 below, and 20 is 4 above. So we can use the data points 12, 200 and 20, 240 to find v prime of 16 through the slope formula, y2 minus y1 over x2 minus x1.
Why do we need to find the slope again?
You find the slope because essentially a derivative is a tangent line, and therefore we are estimating the tangent line at x equals 16. We do this by finding the slope of the line between 12 and 20. So I'm going to do v of 20 minus v of 12 all over 20 minus 12. This gets us 240 minus 200 over 8, and solving the algebra gets us 5. Now don't forget to add units because that's an easy way to not get credit for your answer. Since velocity was meters per minute and v prime is acceleration, we square the bottom to get meters per minute squared. We now know that v prime of 16 is approximately 5 meters per minute squared.
Using correct units, explain the meaning of the definite integral, the integral of 0 to 40, absolute value v of t dt in the context of the problem. Approximate the absolute value of the integral of 0 to 40, absolute value v of t dt using a right-radian sum with 4 subintervals indicated in the table.
Now part B is a very classic problem, where we are asked to explain the meaning of an integral. So we have the integral from 0 to 40 of absolute value of v of t, and they ask us, what does this represent? We know that the integral of just v of t would be total displacement, and adding absolute values makes it the total distance traveled. Distance is how much total ground an object has covered, while displacement is how far an object is from its starting point. Displacement is the difference between the final and initial position of a point, so negative numbers are included. If a person moved 10 units left and then 7 right, that would be 10 minus 7, or a total displacement of 3, since they are only 3 units away from the starting point. On the other hand, distance is adding up all the units a person moved, so all the distances need to be positive, hence the absolute value bars. If a person moved 10 units left and 7 right, they traveled a total distance of 10 plus 7, or 17 units.
There was a second part?
You have to read the full riddle, Annie.
So essentially,
Distance is without absolute value, total is with absolute value. Back to the problem. We can write that the integral is equal to the total distance traveled. Then, we add in the context of the problem to make our answer total meters traveled by Joanna over 0 minutes is less than t, which is less than 40 minutes. The second part of B wants us to approximate the integral using a right-Riemann sum with 4 subintervals. Now we can look at our table and mark how far it is between each t value. Since it is a right-Riemann sum, we will be using the farther right v of t value for each set of 2 data points. For example, the difference between 0 and 12 is 12, and the farther right value of v of t for these 2 points is 200. The area of each rectangle in a right Riemann sum is found by multiplying the width of the base times the right height. For my right Riemann sum, then, I will multiply together the distance between times 12 and the farther right value, 200. Now, I repeat this process on the other values on the table. I go from 12 to 20, which is 8, and the right endpoint is 240. Then I go from 20 to 24, which is 4, and the right endpoint is 220. We make negative 220 positive because we are working with total distance, which is the absolute value of v of t, so v of t will always be positive. Finally, 24 to 40 is 16, and we use the right endpoint of 150. Now, add up each of the individual multiplications or the individual areas of each rectangle. 16 times 150, 4 times 220, 8 times 240, and 12 times 200. For this problem, it is fine to leave your final answer as just that, but since it's in the calculator section, it is also okay to add and multiply everything out. If you choose to do this, the final answer is 7,600 meters.
You mean Mr. Knudsen's riddle, right?
Sorry, right.
Bob is riding his bicycle along the same path. For t is less than or equal to 10 or greater than or equal to 10, Bob's velocity is multiplied by b of t equals t cubed minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Based on the model B from part C, find Bob's average velocity during the interval t is less than or equal to 10 or greater than or equal to 0.
In the next part, the problem introduces a new person, Bob, who's riding his bicycle, and we are asked to find his acceleration. It is important to note that b of t, the equation we are given, is actually velocity, so we already have the first derivative, since velocity is the first derivative of a function. To find acceleration, or the second derivative, all we have to do is find the derivative of Bob's velocity, which we can easily do with the power rule. Using this rule gets us 3t squared minus 12t, and plugging in 5 for t gets us the answer of 15 meters per minute squared for Bob's acceleration. The final part of the question has us finding Bob's average velocity in the first 10 minutes. Average velocity is the keyword. There are two types of average formulas, slope formula and 1 over b minus a times the integral. Since they want us to find the average value of velocity, and we are given velocity, we use the second formula. The problem wants us to find all of Bob's velocity that he had over the time interval. Average velocity is the integral divided by interval. The interval is the highest time, b, minus the lowest time, a. In this case, that is 1 over 10 minus 0, which is 1/10. So we write this as 1/10 times the integral from 0 to 10 of b of t, the velocity given. We can then integrate b of t from 0 to 10 using the reverse power rule to get 1/10 times t to the 4th over 4 minus 6t cubed over 3 plus 300t from 0 to 10. We then use the fundamental theorem of calculus, which is plugging in the upper bound minus the lower bound. Plugging in 0 to the equation gets 0, so we only need to plug in 10 for t. Complete the multiplication, add the terms together, and multiply by 1/10 to get the final answer, 350 meters per minute. For extra review of velocity and acceleration problems, I highly recommend taking a look at question 4 on the 2006 AP Calculus AB exam, or completing the motion problem set on Khan Academy's AP Calculus AB section. Okay, we solved your riddle. Now show us who you are.
You will never catch me!
All right, I'm recording.
That's your line.
I'm rolling. I love that so much.